which we anticipate launching in 2021, which will be able to see farther into the infrared part of the electromagnetic spectrum. That enables us to see some galaxies that are difficult for Hubble to see because they're so far away that their light is traveling through us through expanding space and gets stretched out into redder wavelengths, often far into the infrared part of the spectrum, even sometimes beyond what Hubble is able to detect well. The Webb telescope will give us more information about some of those very distant galaxies.
The James Webb Space Telescope is the follow-on telescope after the Great Hubble Telescope. It extends the discoveries of Hubble into the infrared spectrum region. We think that the first objects that grew out of the Big Bang material probably happened in about 100 million years after that start. And we think the Webb telescope can pick them up. They're rare, they're hard to find, but they should be there. The farthest we've been able to see with the Hubble telescope goes back about 800 million years after the expansion began. So we think we get much closer to the first objects with the Webb telescope.
Hubble gives information that the Webb telescope cannot give about visible and ultraviolet emission from things in the universe. And when we have all that information coming in at the same time, it's like a banquet of scientific return.
Now when we get the complete picture of every wavelength you can possibly see from ultraviolet to infrared, we hope to have the story of the growth of the first galaxies from the primordial material. So that will be a huge accomplishment that depends on both pieces of equipment, the Hubble telescope and the James Webb telescope working together.
So astronomers are very excited about this probability that we'll have both the Hubble Space Telescope and the Webb telescope operating at the same time for quite a few years. That will give us an abundance of new understanding about the universe. And already right now with Hubble, we're doing preparatory observations for the Webb telescope. We're using Hubble to do things, for example, like surveying distant galaxies to find out which ones would be prime targets for the Webb telescope. In fact, scientists around the world are proposing observations with Hubble right now specifically to help us learn information that will be useful for making the best use of the Webb telescope as soon as it's launched and gets going in its science observations.
I think the Hubble telescope has been the most productive science instrument ever built. In astronomy, there's what we knew before Hubble, and now there's what we know after Hubble. They're so different. Of course, Hubble has now had a life of 30 years, so it's had a long time to make this revolution happen. So it's not all at once. It's a gradual revolution, but it's still a huge revolution. Technology has changed dramatically over the 30 years of life of the Hubble telescope. So you couldn't even have imagined when the Hubble was launched that we would have the wonderful cameras and spectrometers that we fly today. We figured out how to send astronauts, we trained the astronauts, we figured out what instruments could be put in, we figured out how to repair everything that went wrong on the Hubble, and it's still alive today, 30 years after launch. And I am so thrilled to say that our people were able to do that. That's the operations team that makes this possible. It's a miracle as far as I'm concerned, because it didn't have to be that way, but they made it happen.
Good evening from Mission Control Houston and the International Space Station Flight Control Room. Flight controllers here are working with their counterparts across the ocean at the Russian Mission Control Center outside of Moscow in the town of Korolyov as we stand by in the final minutes of the flight of a veteran Russian cosmonaut, a Russian actress, and her producer-director, who are now flying aboard the Soyuz MS-18 spacecraft following its undocking from the International Space Station a couple of hours ago. Oleg Novitsky, the Soyuz commander and veteran Russian cosmonaut, about to wrap up 191 days in space on this, his third flight into space, flanked on his left by Russian director-producer Klim Shipenko, spaceflight participant and board engineer number 1 for this descent back to Earth and a landing on the steppe of Kazakhstan. On the right, or to Novitsky's right, is Yulia Peresild, the Russian actress who has joined Shipenko over the past 12 days since they were launched from the Baikonur Cosmodrome in Kazakhstan on the Soyuz MS-19 spacecraft, with another Russian cosmonaut, Anton Shkaplerov, arriving on the station for 12 days of movie making for a film titled Challenge, in which Peresild portrays a surgeon dispatched to the International Space Station to attend to an ailing crew member. With their movie making having come to an end, after a productive 12 days of film acquisition, shooting scenes aboard the International Space Station, the 3 crew members are now poised for a deorbit burn that is coming up 24.5 minutes from now that will slow the Soyuz down and allow it to drop out of orbit for its high-speed entry back into the Earth's atmosphere and a landing on the steppe of Kazakhstan about 92 miles to the southeast of the town of Zhezkazgan. As mentioned just a bit over 2 hours ago at 8:14 p.m. Central Time, 9:14 p.m. Eastern Time, the Soyuz MS-18 undocked from the Nauka multipurpose laboratory module on the Earth-facing side of the Russian segment of the International Space Station. Hooks were driven open, holding the Soyuz to Nauka, and springs on both sides of the docking interface pushed off against one another to enable physical separation. The Soyuz executed a couple of separation burns, small engine firings, to create an opening rate from the International Space Station, drifting away to a point at which it is now, as we stand by for the deorbit burn that will begin the final leg of the journey home for Novitsky, Peresild, and Shipenko. Earlier in the evening, the crew members had an opportunity to say farewell to their counterparts on board the International Space Station. Peresild in the red jumpsuit, Shipenko at the hatchway, Oleg Novitsky in the white flight suit, as they climbed aboard the Soyuz MS-18 to begin donning their Sokol launch and entry suits and conducting leak checks at the docking interface between the Soyuz and the Nauka multipurpose laboratory module. In the foreground there, in this replay from earlier today, Anton Shkaplerov, the veteran Russian cosmonaut who launched with Peresild and Shipenko back on October 5th, and who now stays aboard the International Space Station as part of the Expedition 66 crew, Shkaplerov to return to Earth in March of next year with NASA astronaut Mark Vande Hei and Russian cosmonaut Pyotr Dubrov. When Novitsky lands on the steppe of Kazakhstan, with that landing scheduled at 11:35 and 42 seconds p.m. Central Time tonight, just about an hour and a half from now, he will have chalked up 191 days in space on this, his third flight into orbit. On this particular mission, he will have completed 3,056 orbits of the Earth in a journey that has spanned 80.9 million miles. Novitsky's 3-flight total is now going to stand at 531 days in space. He also conducted 3 spacewalks during the mission, including the initial outfitting of the new Nauka multipurpose laboratory module that arrived at the station for its automated docking in late July. For the two spaceflight participants who flew under an arrangement between Roscosmos and Moscow-based media entities, Yulia Peresild, the actress, and her producer-director Klim Shipenko spent 12 days in space, 192 orbits of the Earth, in a mission in which they logged 5.1 million miles.
Copy. Doing good on board. Can hear you loud and clear. Same here.
At this hour, the Russian search and recovery forces, called Rosaviatsia, the civil entity that takes care of the recovery of all returning Soyuz crews from orbit, they are at the airport in Zhezkazgan, which is one of the staging cities for tonight's recovery operations. They will soon be boarding at the time of the deorbit burn. Russian Mi-8 helicopters, rotors spinning, for about a 35-minute helicopter ride down to the landing site, ultimately arriving in a racetrack pattern around the landing zone to await the arrival of the Soyuz under its large main parachute. They will quickly attend to the crew once the landing has occurred, landing their helicopters in sequential fashion, one by one, erecting a inflatable medical tent near the capsule itself, and beginning the process of extracting the crew. It should be Novitsky out of the spacecraft first, since he is in the center seat of the Soyuz, followed by Shipenko and Peresild. They'll have a few minutes to get their legs back, their land legs back, after their time in a weightless environment, as they sit in those chairs near their capsule before being carried into that inflatable medical tent to get out of their Russian Sokol launch and entry suits and into more comfortable clothing. They'll be brought back to 3 different helicopters waiting in that landing zone to fly about 2 hours back to the staging city of Karaganda, Kazakhstan, where they will then board a Gagarin Cosmonaut Training Center aircraft for a flight back to the training base in Star City, Russia, outside of Moscow. This is the first time that an all-Russian crew has returned home in a Soyuz spacecraft since June 16, 2000, when cosmonauts Sergei Zayotyn and Alexander Kalery landed in a Soyuz vehicle after decommissioning the Mir space station. In the past few minutes, flight controllers at the Russian Mission Control Center, and again you're looking at a live view of that cavernous flight control room from a balcony camera overlooking the flight controllers who are on console there, monitoring all of their data. One of the flight controllers, in conversation with Oleg Novitsky, explained what the weather conditions were like at the landing site, and they appear to be ideal. Clear skies on a Sunday morning on the steppe of Kazakhstan, with very light winds. Temperatures in the low to mid-40s expected to greet the trio upon their arrival.
And please say hello from all of us up here on the station. Well, we already missed being on the station, so I'm already looking into opportunities to come back. Well, next time we'll see you on Earth. Yes, bye-bye. Bye.
A brief exchange between Anton Shkaplerov on the International Space Station and the crew aboard the Soyuz, wishing them all the best as they soon will begin their journey back to Earth with a deorbit burn just 17 minutes from now. This will be a 4-minute, 38-second retrograde firing of the Soyuz engines that will slow the Soyuz down by 128 meters per second, allowing it to drop out of orbit for its return to Earth. Some 29 minutes after the deorbit burn, there will be a pyrotechnic separation of the 3 sections of the Soyuz the module separation coming at an altitude of about 140 kilometers. This will enable the descent module, where the crew is strapped in to their respective seats in their SOCA launch and entry suits, to be traveling in the direction that will enable the Soyuz to enter the region of plasma, the peak heating region, where the heat shield will repel temperatures building up to about 2,500 degrees around the spacecraft for 5 minutes of a fireball, basically, that the crew will be descending back to Earth in. Once they exit that plasma regime at an altitude of about 37 kilometers, the next major milestone will come at 11:21 p.m. Central Time, 12:21 a.m. Eastern Time, when the command will be issued to open up the parachutes. First, a drogue chute will be deployed, followed by the main chute at 10.7 kilometers in altitude. The jettisoning of the heat shield will follow, and that will expose the braking rockets at the base of the Soyuz, along with the altimeter that will send information back to the onboard computers to calculate its rate of descent and its altitude above the Earth. And finally, the braking rockets will fire just a few seconds before touchdown, and the crew will be back on Earth. Landing is scheduled 92 miles to the southeast of Jezkazgan, Kazakhstan, at 11:35 and 42 seconds p.m. Central Time, which will be 10:35 and 42 seconds a.m. Kazakhstan time at the landing site. One of the characteristics of a Soyuz descent back to Earth is that a short time following the completion of the deorbit burn, about 10 seconds after the burn is complete, the upper section or the orbital module of the three-section Soyuz spacecraft will be depressurized. That, in essence, sets the stage for the module separation, the pyrotechnic firing that will separate the three sections of the Soyuz from one another. The Soyuz will move just right after that to a range of some 125 kilometers away from the International Space Station, at which time VHF voice communications is expected to be at best ratty and perhaps unavailable, as the geometry of the Soyuz antennas and the antennas on the International Space Station becomes no longer useful for voice communication back to the ground. You'll hear a beep, beep, beep sound. That is the radar system on the Soyuz communicating beacon signals, basically, that will be picked up by the Antonov fixed-wing aircraft that will be flying around the landing site, serving as an airborne command and relay center to relay information about the condition of the crew and the progress of the Soyuz as it descends back to Earth to the flight controllers that you see there in the Russian Mission Control Center in Korolyov. Coming up on about 12 and a half minutes until the deorbit burn, everything on the Soyuz is in good shape. The crew reported to be in good shape and good spirits on board as they prepare for the final leg of their journey back to Earth and a completion of 12 days of movie making aboard the International Space Station. The Expedition 66 crew on board the station, which is asleep at this hour, with the exception of the two Russian cosmonauts, Anton Shkaplerov and Pyotr Dubrov, they are now a new increment, the Expedition 66 increment beginning formally at the time of the undocking of the Soyuz a little over 2 hours ago. The commander of the space station, European Space Agency astronaut Thomas Pesquet, will be in control of station operations for the next couple of weeks until he hands over command of the station to Shkaplerov before Pesquet returns to Earth himself with his Crew Dragon crewmates of Shane Kimbrough, Megan MacArthur, and Japan Aerospace Exploration Agency astronaut Aki Hoshide. They are scheduled to return to Earth in early November.
You're feeling great? And everything's good? All right, everything's fine, and we are standing by for the EKV inhibit command. That's right.
The Russian flight controllers told Novitsky a short time ago that because the communications between the ground and the Soyuz spacecraft are expected to be somewhat intermittent at best, perhaps non-existent, they have advised him to continue reporting on the condition of the Soyuz and the condition of he and his crewmates, even if there's no response that he hears on board from the Russian flight controllers. You will hear them call the spacecraft by Novitsky's call sign of Kazbek. That's one of the major mountains in the Caucasus and one of the 10 highest peaks in Russia, Novitsky choosing as all Soyuz. Coming up on the 8.5-minute mark before the initiation of the deorbit burn using the Soyuz main engine. Again, this will be a 4-minute, 38-second retrograde maneuver, a braking maneuver, to slow the Soyuz down by 128 meters per second. During the course of that deorbit burn, Novitsky will be calling out duration and chamber pressure readings. You'll be hearing that through the interpreter.
Так, есть разворот.
Maneuver confirmed, and that's on display 42. Copy. Oleg, I confirm in attitude, and I'm sending the unintelligible command. So please set in the Delta V, please also set in the burn and report on the progress and the result of the burn. Copy. Just provide a running commentary to us. Will do. And S9 command. S9 is illuminated. Copy.
The Soyuz is reported to be in the correct orientation for the deorbit burn that will begin less than 6.5 minutes from now.
Moscow, this is Kazbek. Everything's fine on board. Copy.
Олег, на IMPO-1 формат контроль.
Oleg, please select control on display on the input panel 1. And just wanted to say that in attitude is set to maneuver. Great. Let's look at, we can actually look at the table that's on the control display.
Принято.
Copy.
Five minutes now until the deorbit burn. Everything in good shape on the Soyuz. At the airport in Desacoplamento, which is where the Russian Mi-8 helicopters have been staged, the selected recovery personnel in those helicopters have their helicopter rotors spinning, ready to take off one by one for about a 35-minute helicopter ride down to the landing site, where they will be pre-positioned in a racetrack pattern to await the arrival of the Soyuz under its main chute. You can see the trajectory as the Soyuz will move from southwest to northeast to its landing site, about 92 miles to the southeast of Desacoplamento.
Олег, за минуту до включения двигателя.
Oleg, 1 minute prior to thruster activation, please monitor BIOS power supply and GSO in attitude. Copy.
Coming up on the 2-minute mark until the start of the deorbit burn. Again, this will be a 4-minute, 38-second engine firing to begin the trip home for Novitsky, Parasild, and Shapenko. One minute till the deorbit burn begins.
1 minute to SKD activation, and we confirm SKD cover is open. We confirm power to BIOS in attitude GSO. and we confirm mode stable. G3 command for COM session activation has been sent. We copy.
Есть готовность BIOS на СУС.
BIOS and SUS are ready.
Принято.
10 seconds from the deorbit burn.
Есть включение двигателя.
Thrust activation is confirmed.
Принято.
Deorbit burn is now underway.
15 секунд.
15 minutes. First burn, 0.46. Parameters are all nominal. 30 seconds. Burn is 14 meters.
Принято.
Copy.
Good parameters so far being reported by Novitsky on board the Soyuz MS-18.
Принято.
We copy all.
Минута 10.
1 minute, 10 seconds. All parameters are nominal.
Принято.
3:47. We copy.
Минута 3.
1 minute, 30 seconds.
1 minute, 38 seconds into the burn, 3 minutes to go. Everything reported to be going well.
And then 0.47. We copy all.
Две минуты 54,7. NX 047. Параметр норма.
2 minutes, 54.7 and 0.47. And everything's nominal on board. We copy all.
Время 2:20, импульс 64.
2:20. The burn is 64. We copy.
2:30, 60.
2:30. 69.3.
Принято.
Copy.
Две минуты 55.
2 minutes, 55 seconds. 81.9 and then 0.48. And all parameters are nominal.
Три минуты 15.
3 minutes, 15 seconds, 91.3, 0.48. All the parameters, the burn is 91.3. All the parameters are nominal. We copy.
Три 40.
3:40. Burn is 102.5.
Параметр
0.48 is a second number, and everything's fine on board. Copy.
Less than a minute left in the deorbit burn, everything going well.
4 минуты.
4 minutes, 112.5 for the burn.
Принято.
Copy.
420, 122 метра.
122 meters at 4
Ожидаем ГК.
minutes 20 seconds.
Standing by for a nominal cutoff.
For SEGAK main engine cutoff.
Двигателя.
And we confirm.
And we have the end of the deorbit burn. It was a nominal burn. A veteran Russian actress, her producer-director, and a veteran Russian cosmonaut are on their way home.
Copy.
As the deorbit burn was completed, the Russian Mi-8 helicopters at the airport in Zhezkazgan began to depart one by one, headed for the landing site to await the arrival of the Soyuz MS-18 under its main parachute.
Так, работа по странице 56.
And I'm moving on to page 56. Guys, page 56.
До разделения
Copy.
чуть меньше 23 минут.
And there is less than 23 minutes till separation.
Олег,
Copy.
смотри, пожалуйста,
Oleg,
время ГК.
could you please verify what was GK time?
Сейчас, секунду.
I copy. Please stand by.
Так, ГК 06,
GK
19.
064619.
6:19.
Okay? 064619. Right.
Какой импульс отработали?
And could you please check what burn are you done with?
7,99.
Well, it was 127.99 for the burn. Wonderful.
Давление в БО 89, 786.
Barrel pressure is 89 and descent module pressure SR is 786. Copy.
Так, по странице 56, не позднее переделили минус
All right.
4.
No later than separation 0647. And
Верно. Ну, время отслеживайте по
so talking over each other. So no later T separation minus 06.
Так, Юль, дашь мне?
Yulia, could you give me the rotational hand control? It needs